The aim of this research is to consider the efficacy of the solar cells for big-sized commercial buildings facing the challenges the new directives have established. The case study is Shopping Light Mall, being located in the center of the city of São Paulo. To measure the efficacy of solar cells, a theoretical retrofitting operation was considered. This exposition has the following structure: a starting point explaining the environmental problems that motivate the study of the theoretical retrofitting, the aims of the research, the case study, and the conclusions. With the aim of appointing an original starting point for the current research, the chosen one was the concept of sustainability, established by Dr. Bernard Harlem in the 1987 United Nations Summit called Our Common Future. This concept considers three pillars, which are the economical reliability, the social engagement, and the maintenance of the environment. The current research is focused only in the pillar of environment, and considering this pillar, different governments have started to approve laws and directives related to ecological challenges. And some of these directives are the headlines of the current research. The aim of this is the study of a theoretical energetic retrofitting of the Shopping Light Mall place in São Paulo. Being of importance, the impact can have. The results of this study were compared with the aims of the following directives. The first one is the primitive Kyoto Protocol established in 1997, which considers a reduction of emissions in a 5% in the time from year 2008 up to 2012. The second directive to be studied is slightly more ambitious, being this one the second phase of the Kyoto Protocol of Summit Doha COP18 taking place in 2012, which established a reduction of emissions of 15% by 2020. The third one is having more ambitious aims is Europe 2020 Directive, considering as main goal a 20% reduction of greenhouse gases, the reduction of energy consumption by a 20%, and a coverage of 20% of the energy demand by clean energies, all by year 2020. Shopping Light Mall, located in the center of São Paulo, have been considered a historical building by local authorities. This large commercial facility has a surface of 36,000 square meters in 5 stories, being visited by 75,000 people per week. The importance of this case is because it's a large both commercial and representative building with a high rate of energy consumption due to its large surface. As a previous step for the study of the theoretical energetic retrofitting with solar cells is the establishment of the area to be retrofitted. In this case, this area is the roof of the Shopping Light Mall, having a surface of 3010 square meters. The analysis of this retrofitting starts with the taking of data related to solar irradiation. In the following video is shown how does the sun cast shadows on the mall and nearby environment, being the zero azimuth, the north orientation because of the location in southern hemisphere. As a resume of this study, the following table was done, considering the percentage per hour the sun casts direct irradiation on the Shopping Light roof. This is of application to calculate the amount of energy can be generated by solar cells applying the handicap of shadows. The table shows that the percentage of the time Shopping Light roof is exposed to sun irradiation was estimated in a 77% approximately related to the total yearly daytime hours. The next step to be considered was to estimate the energy casted by the sun irradiation for the climate and latitude of the city of São Paulo. The following graph shows the result of the application of a programmed spreadsheet done by Javier Neila where both latitude and cloud index of São Paulo were inserted. The results are referred on a flat surface with no obstacles. This data is the starting point to estimate the energy can be generated by solar cells in São Paulo. Once all analyses related to solar irradiation were done, the next step is to estimate the energy can be generated in absolute values. Furthermore, Intemper Company Technical Service estimated this amount of energy generated for the electrical supply by using the Filtron tile I-40, considering an area of 500 square meters without obstacles to sun irradiation. These calculus were done for the climate of the Spanish town of Vitoria-Gasteiz, located in northern Spain, having this town different solar conditions than São Paulo. To solve this problem, an interpolation of this data was done, using the solar irradiation obtained in the NEILAS spreadsheet for both São Paulo and Vitoria-Gasteiz. The results of this interpolation shows that the Filtron E40 tile used in Sao Paulo climatic conditions can generate about 98 kilowatts per hour and per square meter of tile. The final step in the calculation process was to estimate the solar energy can be generated by the solar cells formerly appointed in the conditions of shopping light mall roof. Furthermore, the surface of shopping light roof was multiplied by the energy generated per square meter of solar tile calculated before, and the application of the percentage of sun exposure calculated in the table. The result is that the coverage of the shopping light mall roof with Intemper E40 solar tiles can generate about 227,000 kilowatts per hour and per year. Towards the conclusions, was important to consider the impact of the theoretical retrofitting study. By this way, an estimation of energy consumption was done using the program of the EDITE CE3X, considering both the constructive features of shopping light and its installations. As a drawback, this program does not consider Brazilian climatic conditions, so the temperature data inserted for this simulation were the one of this town of Santa Cruz de Tenerife, similar in temperatures to São Paulo, as the graph shows, being also readapted the orientation of the facades. The result of this simulation was an energy consumption of about 356 kilowatts per hour per square meter and per year, and a rate of yearly carbon dioxide emissions of 0.095 tons per square meter of building per year. By comparing the studies done with C3X and the theoretical retrofitting results related to carbon dioxide emissions, the energy generated by solar cells per year was inserted in a second calculation using C3X. The following results were obtained. A reduction of 0.012 tons per square meter per year was achieved, and this reduction supposes an 8.6% of the emissions of the shopping light mall. Also comparing the energy generated by solar cells formerly obtained with the yearly energy consumption of shopping light mall, the result obtained is that the rate of usage of solar energy after the theoretical retrofitting was estimated in about 2.1%. However, it's important to consider that according to the International Council for Local Environmental Initiatives, the 19% of the energy used by the city of São Paulo comes from hydroelectric sources. This was not considered as positive for the current research because the challenge shopping light mall must achieve, though, is the energetic self-dependence on energetic sources. This is because these favorable energetic conditions does not apply in every city of the world. To establish the conclusions, the favorable effects achieved by the usage of solar cells were compared with the directives explained at the beginning of the lecture. As shown in the graph, the application of solar cells only on the roof would allow shopping light mall to comply with the requirements of primitive Kyoto Protocol. However, these achievements are still far from other initiatives with more ambitious environmental objectives, such as the current phase of Kyoto Protocol or the Europe 2020 initiatives. It's important to consider that Brazil is not included in these two directives though, so another challenge is the adaptation of the environmental challenges to the technological capabilities and conditions of each country in the world. And to sum up the conclusions of the study. At first, it makes important the fact that buildings of relevance in the city owned by influenced private landlords or local authorities must be an example of correct energy management, following by this way exemplar solutions for the city. The second conclusion is the fact that the application of solar cells on the roof only is not enough to comply with the directives and initiatives which have ambitious goals in environmental requirements. In addition, these initiatives are not related to concrete cases such as shopping malls. Mixed solutions of environmental retrofitting are going to be required. At third place is going to be necessary the availability of an accessible register of consumption and carbon dioxide emissions data related to shopping malls. The aim is to guarantee any future operation of environmental retrofitting the shopping mall to be truly effective. And this is the end of the lecture. I sincerely glad your attention, being disappointingly not possible to be with you in this day. Thanks for all.